Okay, so good morning, ladies and gentlemen. This morning we begin with Eth-Trunk, principles and configuration. Mzuri sana Sunde. So we begin with Ethernet trunk principles and configuration. Most of the concepts here we already looked at when we were doing HCIA. Just a few new concepts maybe. So as the number of services deployed on networks increases, then the bandwidth of full duplex point-to-point links cannot meet the requirements of normal service traffic. So as devices increase on the network, then the bandwidth of full duplex point-to-point links cannot meet requirements of normal service traffic. So the interface cards with higher bandwidth can be used to replace existing interface cards to increase bandwidth. So the reason as to why these point-to-point links cannot meet requirement is because of the bandwidth. Because when the number of devices increases, then you're having higher traffic. So one solution to that is you replace existing interface cards with higher bandwidth interface cards. However, these will waste existing device resources because the interface cards that you're removing are simply going to lack any function, and it will also increase the upgrade expenditure. So that's the problem with replacing existing interface cards. So if more links are used to interconnect devices, each layer 3 interface must also be configured with an IP address, thereby wasting IP addresses. So also, if we have to configure more links between devices in order to increase bandwidth, each of the link, if it's a layer 3 link, it must be configured with an IP address, and therefore it's going to waste IP addresses. So the solution to all these problems is what we call link aggregation. Link aggregation, also referred to as Eth-Trunk. So it's a binding technology that can bundle multiple independent physical interfaces into a logical interface with high bandwidth. So there's no need to replace interface cards, and IP addresses are not wasted. So some of the advantages there of link aggregation. So this course describes the Eth-Trunk technology. This course describes the Eth-Trunk technology. So by the end of this chapter, you should be able to. By the end of this chapter, you should be able to. A volunteer can read for us.
Upon completion of this section, you'll be able to, 1, be familiar with Eth-Trunk principle.
Yes.
2, master the Eth-Trunk configuration.
Exactly. Okay, so let's begin with Eth-Trunk principles. So, you remember we talked of the hierarchical architecture of our network, which has layers, such as the access layer that interconnects the end devices, aggregation layer that picks the data, where data congregates before it goes to the core layer. Then at the core layer, you are now connecting to the internet. Now, generally, in order to make your network resilient and also, what do we call it? And also reliable, there are things that you need to do. Now, let's begin by looking at this. So for example, here, we have an aggregation switch and an access switch, which have been connected using a single link. So what risks What risks does that pose to the people in the finance area? What risk does that pose to the people in the finance area? The risk is that if this single link goes down, if that single link goes down, then people in the finance department are not going to access the network or the internet. So that's one of the problems with single links. Now, if we also look at the interconnection between this router and this layer 3 switch, okay, and this layer 3 switch, we can see here that we also have a single link. We have a single link interconnecting them. Now, the other problem with a single link is the bandwidth. So the bandwidth of a single link cannot meet traffic requirements of the entire campus network. So if high bandwidth interface cards are used, then the device maintenance costs are added. So that's the disadvantage. We can replace these cards here so that, for example, if they were 1 gig, we go for 10 gig interface cards. But that will also increase the maintenance cost. So if links are added, if we add another link, for example, we can also add another link here between these two. We add another link to interconnect this switch to this router. So when that happens like that, the problem is IP addresses. They have to be assigned IP addresses, and therefore that wastes. It actually wastes IP addresses. So that's the challenge. That's the challenge and network issues that you might consider when you're designing a network. That single links form what we call a single point of failure. And number 2, they have issues with bandwidth. And if they're layer 3 links, then they can also waste. They can also waste IP addresses. So what is the solution? What is the solution to single links? What is the solution to single links? The solution to these single links is what we call link aggregation, where we bundle several physical interfaces into a single logical interface. This technology of bundling physical interfaces so that they work as a single, multiple physical interfaces so that they work as a single logical interface is known as Eth-Trunk. Eth-Trunk technology. So that's the official name. Eth-Trunk technology. Now the reason as to why it's called Eth-Trunk, as you might have already guessed, ETH there is from Ethernet. Ethernet. So with Eth-Trunk technology, only Ethernet interfaces can join the Eth-Trunk. So you might not be able to bundle, for example, serial interfaces into an Eth-Trunk. Okay, so let's look at how this is done. So a few concepts, most of this just reminders from the previous module. So as we said, we have an interconnection. We have an interconnection between RTA and RTB. We can always bundle this into a single Ethernet trunk. Now, this will cater for the challenges that we saw in the previous slide in these ways. Number 1, the total bandwidth of the Ethernet trunk will be the sum of the individual bandwidths of these interfaces. So if this is 1 gig, this is 1 gig, this is 1 gig, then the bandwidth for this Ethernet trunk is going to be 3 gig. Therefore, it increases bandwidth between RTA and RTB. On saving IP resources, you'll only have to assign a single IP address for this Ethernet trunk on both ends. So just a single, other than using 3. Without using Ethernet trunk technology, you have to have 3 IP addresses between RTA and RTB. And also here, of course, you must have 3. So in total, actually, you must have 6 IP addresses. But when you create an Ethernet trunk, by combining these 3 physical interfaces, you only have 2. You see, it really saves IP addresses. So Ethernet trunk is a binding technology that bundles multiple interfaces into a logical interface. Now, generally, we have 2 modes. We have 2 Ethernet trunk modes. The first one is known as the manual load balancing mode. This is the default mode. So anytime you're creating an Ethernet trunk, it will be working on the manual load balancing mode. Then the other one is known as static LACP mode. LACP for link aggregation control protocol mode. So while this one you have to manually configure, as the name suggests, this one uses a protocol to bundle up the links. Now, other than saving IP addresses and also increasing bandwidth, the other advantages of link aggregation includes load balancing. Load balancing means each of these link is going to carry data in equal percentages. So that is what we call load balancing. Then it also enhances reliability in your network. Reliability means if we had a single link between RTA and RTB, if that link goes down, then you've isolated. RTB and RTA cannot communicate. But with this kind of design, when you create an Ethernet trunk, when one link goes down, the other physical links will continue forwarding data. And therefore, you're not going to isolate people, for example, who are connected to RTB or RTA. So it's also very important in improving your network reliability. Now, generally, you can bundle up both layer 2 and layer 3 links. Layer 2 links, layer 2, they forward using MAC address. Layer 3 links, they forward using IP addresses. So you can use either. You can bundle either link types, and you're going to see how in a short while. Okay, so let's begin by looking at the manual load balancing mode. So with manual load balancing mode, what happens? So when at least one device of 2 devices does not support the LACP protocol, link aggregation control protocol, then you can configure the Ethernet trunk in manual load balancing mode in order to increase bandwidth between the 2 devices and improve reliability. Now, what is very important to remember is that in manual load balancing mode, all links added to the Ethernet trunk forward data. So most of the time, it is advised that you configure Ethernet trunk using LACP. LACP, when you use a protocol, dynamic is easier to maintain because it can handle failures on its own. But manual is more involving. But sometimes in your network, you might have an old device that does not support LACP protocol. So whenever any device in your network is unable to support, for example, LACP protocol, then you have to configure all of them with manual load balancing mode. What is important to remember is that in manual load balancing mode, all links forward data in load balancing mode, meaning each link actually forwards data with equal percentages. So maybe if there are 33.333% of the data will pass through this link like that. So that is what we call manual load balancing mode. Now the next one is LACP. LACP mode, the link aggregation control protocol mode. The main difference between LACP and manual mode is that in LACP, some links forward data, and those links that forward data are referred to as active links, while other links act as backup links. Backup links to ensure network reliability. Now, LACP, static LACP mode, is also called the M2N mode, where M refers to the number of active links, while N refers to the number of backup links. So, for example, we can see here between RT and RTB, we are bundling three lines into an Ethernet trunk. Now, as you can see with this red arrow here, these two links are forwarding data, while this link here is not forwarding data. So this one is the backup link. So M to N here is just 2 to 1, 2 to 1, 2 to 1. So generally, that is what we call the LACP mode, the LACP mode. Okay, now there's what we call, there's what we call the actual bandwidth, and there's also what we call the maximum bandwidth. Now, the actual bandwidth is the sum of M links. So that is what we call the actual bandwidth. On the other hand, the maximum bandwidth of an Ethernet trunk in LACP mode is M plus N. So the bandwidth, the sum of the M's plus the sum of the N's. So the sum of the active links plus the sum of the backup links. So actual bandwidth and maximum bandwidth. So for example, if these particular interfaces here, if these interfaces are 1 gig, then the actual bandwidth of this Ethernet trunk is 1 plus 1. So sum of the active links 1 plus 1, which becomes 2 gig. Now the maximum bandwidth is 1 plus 1 plus 1, which is 3 gig. So it's also important to understand that the difference between those two. Okay, so let's move on and look at how. Here we look at how LACP, Link Aggregation Control Protocol, selects what we call an active link. So we talked of an active link, and we've also talked about a backup link. Now, generally, when devices are enabled with LACP, when an Ethernet trunk is enabled with LACP mode, the two devices are going to exchange what we call LACP PDUs, protocol data units. Now, these LACP PDUs are going to share certain information. They're going to share certain information between the devices. So one of the information they're going to share is the system priority. So what's your priority? You're also going to share your MAC address. You're also going to share your interface priority. You're also going to share your interface number. Your interface number. Now, generally, for the system priority, these you can configure. but by default, all switches have the system priority of 32.768. The interface priority can also be configured. The interface priority can also be configured. Do we have a default? I think we have a default, and I think it's 1, but I'll confirm that in the coming slide. But I think the default interface priority is 1. So we also have the MAC address. So the MAC address is just the MAC address of that particular switch. Then the interface number is the number of that interface. For example, this is G001, this is G002. So EO 001, 002, 003 is what you're referring to the interface number. Now, these parameters are used in selecting what we call an active, an actor, in selecting what we call an actor, and also in selecting the active links. So let's see how from this particular example here. So RT and RTB have been interconnected using the interfaces 1, 2, 3, 3 to 1 on the other side, and they have enabled LACP mode to bundle these particular links together. Now, they're going to exchange LACP PDUs to share this information that I've just listed here. Now, whoever becomes the actor is the one that has a lower value of the system priority. Whoever has a lower value of the system priority becomes the actor. Now, we've said that the default system priority is 32.768. In case RTA and RTB, have the same system priority, then what breaks the tie to decide who becomes the actor is the MAC address. So whoever has a lower MAC address becomes the actor. So that is how an actor is actually selected. What is the purpose of the actor? The function of the actor is to decide which links are going to be active and which links are going to be backup links. So that's the purpose of the actor. So that is how the actor is actually selected. Now, after selecting the actor, the next thing they need to do is now the actor will compare the interface priority to determine the active links, the interface priority. So we're going to see the default interface priority, but in case all of them have an equal interface priority, then the next thing the actor will look at is the interface number. So whoever has a smaller interface number becomes an active link. So for example, here we have 3 links, 1, 2, 3. So the actor will select 1 and 2 because they have a smaller interface number to become the active links. Then the last link here is left to be the backup. So generally, that is how an active link is. Active links are selected in link aggregation protocol. Okay, so another important concept is on the preemption. Sorry, what did I do? Okay. So what is LACP preemption? Now, preemption is this. We've said that we can set up active links and backup links. Now, in case an active link goes down, then an interface, a backup interface with the highest priority replaces it and starts forwarding data, because backup do not forward data. So that is how it happens. But what happens then if this guy comes back up This guy had gone down, but now the issue has been resolved and now it's up. So what happens? Will it preempt this one? Will it preempt this one? Preempting mean, will it disable this one so that this one goes back to the backup and this one continues to forward data? So that is what we call preemption. So preemption is, that is one of the scenarios of preemption. Now, let's see. So here, port 1 of the actor fails. So port 3 becomes the active interface to forward data. Port 3 becomes the active interface to forward data. Now, before port 3 becomes the before port 3 becomes an active interface, it waits for a certain predetermined amount of time, which is called the preemption delay. The preemption delay. So you can configure, you can actually configure in your switch what we call the preemption delay. Preemption delay. So it has to wait for that time to expire before it becomes active. Reason being, so that all the MAC addresses that are associated with the link that has gone down can be cleared. So just to give that time to the interconnected devices to clear the data for the interface that has gone down. So that is what we call the preemption delay. Preemption delay. Now, if what we call preemption, is enabled, then when port 1 is restored, then port 1 becomes the active interface. Again, it has to wait for the preemption delay to expire. So that is exactly what you're seeing here, that now this guy comes back up. It waits for the preemption delay to expire and then sends this guy back to the backup link to be a backup link. So for that to happen, you must set the preemption. You must enable preemption. Otherwise, if preemption has not been enabled, then this is not going to happen. This is not going to happen really. So if this comes back up, then it remains as a backup link. Simply remains as a backup link until someone else fails, either 2 or 3 fails. That is when it's going to be considered again. So that is when you've not enabled preemption. Otherwise, if you've enabled preemption, then it's going to take over as soon as it is restored. So that is what we call preemption. LACP preemption. Okay. So let's look at Ethernet trunk load balancing. So when packets are load balanced on an Ethernet trunk, you can use either what we call a flow-based or packet-based load balancing. You can also set the weight of load balancing. So 2 things. You can choose the load balancing mode, and you can also set the weight of the load balancing. So on an Ethernet trunk, the larger the weight of a member link, the heavier the load over that particular link. So what is a flow-based load balancing? So flow-based forwards data flows. They forward data flows over the same physical link. So how is a data flow identified? Any packets that have the same source or destination IP address, or they have the same source and destination MAC address, are simply forwarded over the same physical link. And so that is what we call flow-based packet load balancing. Then we have packet-based. So packet-based is the packets are simply transmitted over different member links, irrespective of whether they are a data flow. So packets, even from the same data flow, will be forwarded over different member links. So that's the difference between flow-based and packet-based. When you do the lab, you're going to see that in order to configure a load balancing mode, you have to go into a particular Ethernet trunk. So for example, Eth-Trunk 1, then when you're in that view, you can use the command load balance, then you can now put a particular, you can either use IP to use the packet-based, to use the flow-based, or you can use the command packet all. By default, packets are load balanced on the IP address of packets. So using flow-based. So when you use the option IP, you use flow-based. When you use packet all, you use packet-based. But by default, they are forwarded using that particular method. Okay, so I hope that is clear. Let's go ahead. Oh, I didn't talk about the weight, I'm sorry. Here, so we also talked about the weight, that you can set the weight of load balancing. Now, generally, when we are using, when you're using load balancing, the default is that all active links forward, they forward with the same percentage. They say they forward with the same percentage. So if they're 2, then 50-50. If they're 3, 33.33 of the data. But when we set the weight, then we can say that we want port 2 to forward 70% of the packets, port 1 to forward 30%. So that is what the weight is. So with the weight, the larger the weight of a member link, then the heavier the load for that particular member link. Actually, the default weight for any member of the Ethernet trunk is 1. So the default weight is 1. So in case you want to change the weight, if you want to change the weight of an interface, you go into the particular interface. So for example, G001, then you use the command distribute weight, then you put a value, for example, 2. So if there are only 2 member links that are forwarding data in load balancing mode, the other one has 1, this one has 2. So this one is going to forward two times more data than the other one. So that is how you configure. That is how you configure a larger weight so that an interface can forward more data. So Ethernet trunk configuration is quite easy. The first thing you have to do is to create an Ethernet trunk. Then you configure the aggregation mode that you want to use. Do you want to use manual load balancing or LACP? Then after that, you add member interfaces. So generally, that is how that is done. But there are also rules to consider. There are also rules to consider when you're configuring. There are some rules that you should consider when you're configuring an Ethernet trunk, for example, member interfaces. Member interfaces cannot have layer 3 configurations, such as IP addresses. So that's one of them. Another one also, member interfaces cannot be configured with static MAC addresses. So that's the other rule. Another one is an Ethernet trunk. If an Ethernet trunk cannot be nested. Nested is putting something inside another thing. So you cannot create you cannot add an Ethernet trunk into another trunk. So Ethernet trunks cannot be nested. You cannot do that. Also, an Ethernet interface can only join one Eth-Trunk. So in case you want to add an Ethernet interface into another trunk, you have to delete it from the initial trunk. So that's also important. The other one is that an Eth-Trunk can work in layer 2 or layer 3 mode. So it can work either in layer 2, a layer 2 Ethernet trunk, a layer 2 Ethernet trunk will forward data based on the MAC address. Layer 3, you have to configure an IP address to it. You have to configure an IP address to it. So that is what a layer 3 is. Now, the other thing to note about the layer 2 and layer 3 working mode is that actually the working modes on the different ends can be different. That is, you can configure a layer 2 trunk on one end of the connection and configure a layer 3 trunk on the other end of the connection. So I hope you also remember that. Okay, so those are some of the things that you should remember about an Ethernet trunk. So let's look at how to do that. So we have to do a number of things to create the Ethernet trunk between RTA and RTB. So the first thing is to create the Ethernet trunk. Then you configure the working mode. Then you add member interfaces. So how to do that? You create an Ethernet trunk using on system view. So you have to be on system view. Then you use the command interface, then Eth-Trunk, then you give it a number. So for example, so that's what we call the trunk ID. So for example, Eth-Trunk 1. Then after that, you can now use what we call the port switch command. Port switch. So when you do port switch in the Ethernet trunk view and you press enter, it will make that a layer 2. So this is when you want to make it a layer 2 Ethernet trunk, like that. So after that, you can now configure the interface mode by typing mode, then you can type manual. For example, manual load balance. You only do this if you're changing it from LACP. Otherwise, manual is the default. This is the default, so you really don't need to configure it. Okay, then how to add members to how to add member links member interfaces, you do that by, you can do that in one of two ways. You can add it in the Ethernet trunk view. In the Ethernet trunk view, like right now we are in the Ethernet trunk. Right now we are in the Ethernet trunk. So when you want to add a member to the Ethernet trunk, you simply use the command trunk port. So trunk port, then the interface type, for example, gigabit Ethernet, then the number of the interface, for example, 0/0/1. So that is how you add it. That is how you add it there. But otherwise, if we can quit from the Ethernet trunk, then go to a particular interface, for example, int 0/0/2, we can also add it. We can also add it like this. So we simply type in the interface G002, a view, we type Eth-Trunk 1, then enter. So that way, we will have added this particular interface G002 to Ethernet trunk 1. So those are the two ways in which you can add member interfaces to the Ethernet trunk. You can use the trunk port inside the Ethernet trunk view, or you can go into a particular interface and use the Ethernet trunk and Ethernet trunk number or ID, like I've shown you here. So generally, these are the commands that you use in configuring manual load balancing. So let's look at how to do it when it comes to LACP mode. So we want to see how to do the configuration in LACP mode. So we want to enable an Ethernet trunk between RTA and RTB. So the first thing we have to do is to create the Ethernet trunk. Then we configure the working mode as LACP. Then we add member interfaces. Then optionally, we can configure the LACP system priority. So we can alter the priority of RTA so that RTA is elected as the actor. Optionally, we can also set the upper threshold for the number of active interfaces. Optionally, we can also configure the LACP interface priority so that certain links can act as backup links and others as active links. Optionally, we can also enable LACP preemption and also set the preemption delay. So I think we can just look into this very fast. So again, you have to be in system view. So for example, system view. Then how you create the Ethernet trunk is very similar to the other one. So you type interface, then Eth-Trunk, then you give it an ID. Then, for example, in the previous one we created a layer 2 Ethernet trunk. Here we can try and create a layer 3. So to create a layer 3, you can type undo port switch, like that. So this will create a layer 3 Ethernet trunk, like that. Then you can now specify the mode using the command mod LACP static. Then after that, you can go ahead and use the trunk port command to add interfaces. So trunk port G0/0/1, trunk port G, for example, 0/0/2, trunk port G0/0/3. So like that. So that is how you add interfaces there. Then after that, as we've said, optionally, you can configure the LACP system priority. So for example, we want to make RTA. We want to make RTA the actor. So we quit from the Ethernet trunk view so that we go back to system view, then use the command LACP priority. Then you enter a certain value, for example, 4096. If you remember, when we learned about the system priority in HCIA, we said that the system priority has to be configured in multiples of 4096. So when you do that, then RTA will have the lower system priority value, and therefore will be elected as the actor. So other than that, you can also set the upper threshold for the maximum number of interfaces, active interfaces. So to do that, you have to be in the Ethernet trunk view. So let me just go back here. So you have to be in the Ethernet trunk view. Then you use the command maximum active link number. Then you enter a certain value. So for example, 3, like that. So for example, here we have 3 links. We have G001, G02, and 3. So we can set the maximum number to 2, so that LACP will elect 2 active links, then one of them will remain as the backup. So that is how you set the maximum link number. The other thing you can set is the LACP interface priority. So for the interface priority, you have to go into the particular interface. So for example, we want G001 and G002 to be we want G001 and G002 to be active links. So you can go into int G0/0/1. So you have to go there. Then you have to use the LACP priority. Then you enter a certain value. I was supposed to find out the default. Can someone find for me the default interface LACP priority? Can someone find, even through Google? Can someone Google? I'm forgetting the default. The default LACP interface priority. If you get it, just remind us. I'm unable to remember that. Anyone who's got it, you can do it now and tell us. Anyone who's gotten? Anyone? Okay, so during the lab, I think they'll state it somewhere. So please check how to configure the interface, the LACP interface priority. So you go into the interface, then LACP interface priority, then you put the priority value. So in the lab, please take note of that. Okay, so the other thing we can configure lastly is the preemption. So the preemption should also be enabled in the Ethernet trunk. So in the Ethernet trunk, you enable it using the command LACP preempt enable. Then to set the delay, the preemption delay, you do LACP preempt delay. Then you enter a value, for example, 3. So it will delay for 3 seconds before the backup takes over becomes active actually. So that is how you configure LACP mode. So any question? Any question, ladies and gentlemen? Okay, so let's look at a configuration example. So this is the configuration example. So here we have a campus network topology, and in order to improve network reliability, we have to configure link aggregation. We have to configure link aggregation, for example, here between the core layer devices, also here between the aggregation layer switches and the core devices. And you can also do link aggregation between these particular interfaces, that is interconnecting the access switches and the aggregation layer switches. So generally, at this point, maybe you can take a picture. You can take a picture of this topology using your phone, so that we let me just see if we go next. Do we have the topology? No, we just have the configuration. Okay, so you can take a picture of this, so that when you talk of R1, R2, R3, you can know what we are referring to. Okay, so I've just taken mine. Have you been able to take the picture? Yes? Anyone? Guys, are you there?
Yes.
Okay, wonderful. So let's see. So we want to start by configuring R1. So we're using the example of R1. So here we want to configure the core devices. So we want to aggregate between R1 and R2. So you can just check the interface that is connecting R1 and R2. G1/0/0, G1/0/1. So that is what we want to aggregate. So to do that on R1, you have to create the Ethernet trunk by doing interface Eth-Trunk 1. Then, because these are core devices, you have to transit this from a layer 2 to a layer 3 interface using the undo port switch command. Then you can do a description. Descriptions are very important. The command is description. Then in double quotes, you can put the particular description. So for example, here we are saying core R1 to aggregate switch 3. Oh, okay. So here we are actually creating the Ethernet trunk that is connecting R1 and switch 3. Sorry, it's not R1 and R2. So it's actually R1 and switch 3. So the description is very important because it helps the administrator understand the remote device connected to the interface for future maintenance, and so that is important. So because this is a layer 3 Ethernet trunk, we have to assign it an IP address. So from the router side, we assign it an IP address. Okay, then here we are creating Ethernet trunk 2. Now this one is the one that is connecting to R2. Then we do undo port switch. Then we do a description. Then we give it an IP address. After that, we can add interfaces. The interfaces to the Ethernet trunk. So here we are doing interface by interface. So we add 0/0/0 into Eth-Trunk 1, 0/0/1 into Eth-Trunk 1. This is the one that is connecting. This is the one that is connecting to the switch to SW3. Then this one are the interfaces that are connecting to the other router, router 2. So we add them to Eth-Trunk 2, Eth-Trunk 2, like that. Okay, so that's the example. So they're not going to show us about R2 because it's just the same thing. So now let's see how to configure the configuration of the aggregation switch SW3 is used as an example. So here we want to configure SW3. If you check the topology again from your phone, you can see that SW3 is connected to two access switches, SW5 and switch 6, switch 5 and switch 6. So we want to create an Ethernet trunk between switch 3 and switch 5, and between switch 3 and switch 6. So we use interface Eth-Trunk 1. Then you can do a description. So first we are creating an Ethernet trunk that is connecting to the core router. Then after that you can do Eth-Trunk 2, a description. Now note that even though Eth-Trunk 1 that we created in the core router R1 was a layer 3, and this end is actually a layer 2 because we are not doing undo port switch. So by default, an Ethernet trunk is a layer 2 trunk. So that is what I was saying in one of the rules there, that either end of the Ethernet trunk can either be a layer 2 or a layer 3. So Ethernet trunk 1 on the core router R1 is a layer 3, but on switch 3 it is a layer 2. Okay, then we create Eth-Trunk 2 that is connecting to switch 4, also Eth-Trunk 3 that is connecting to access switch 5, also Eth-Trunk 4 that is connecting to the aggregate switch. It's connecting S3 to that particular switch. So after creating all those Ethernet trunks, you go ahead and add the particular interfaces. You add the particular interfaces to their respective Ethernet trunks, as you can see here. So as an example, we can use this one that is connecting to R1. So you simply go to the interface G001, then you use the command Eth-Trunk and the trunk ID. Similarly, you go to that one and add it again to Eth-Trunk 1, like that. So that is the command, and you do the same for all the others. So you're going to do this during the lab. So the access devices. So for the access devices, we are using S5. So you can just look at your topology again to see where S5 is placed, so that you see which Ethernet trunk are we going to add it to. Okay, so we're looking at that as an example. So I'm also confirming from my phone. So switch 5 is connected to switch 3. So create an Ethernet trunk. Because access devices use layer 2 connection, the IP address does not need to be configured. So this is a layer 2 trunk. So we simply do interface Eth-Trunk 1, then we do a description. So this one is connected to switch 3, which is at the aggregate layer. Then after we created that, now we can add the physical interfaces to the Ethernet trunk. So we can add it like that. Okay. So after we've done that, we can always run the display Eth-Trunk command, display Eth-Trunk, then the Eth-Trunk ID, the Ethernet trunk ID. But when you don't specify the ID, it goes to the very first Ethernet trunk, which is Eth-Trunk 1. So we can see the working mode is normal. We can see that the least active link number is that. We can see that the maximum bandwidth affected link number is 8. Operation status is up. Number of up ports in the link trunk is 2. So we can actually see the devices and their weight. the interfaces and their weight by using the display Eth-Trunk command. So that is it about the basics of Ethernet trunk, ladies and gentlemen. I volunteer to help us with the first question and another one with the next question there.
I'll do question number 1.
Thank you, Winnie. Go ahead.
What are the Eth-Trunk link aggregation mode? We have manual load balancing mode and LACP mode.
Thank you very much. That is correct. Another volunteer for the second question there.
In LACP mode,
Yes.
the default system priority. 32768.
Exactly, it's 32,768. That's the default. And remember, I've told you to check the default interface priority. Default interface priority. So please make sure that you help us with that. Make sure that you confirm that when you're doing the lab. Otherwise, thank you very much.